Okay, I wanted to do a update on my solar and also on this MPP solar. This is the inverter, charger, grid tie inverter. It'll do multiple things, and it has a whole lot of programming and settings, which I may go over later in a video. There is some online, but the reason I'm doing this is because there's a little bit of confusion, and I was a little bit confused on actually how this thing was worked, and then how to best utilize it. Okay, so this is a HV LV 2424. There's a lot of your capacities and voltages. And the nice thing about this is what I really like about it is this will run up to 140 or 150 volts DC. Okay, so it's a 24 volt. So your battery bank, which is over here, is my battery bank, and these are all lithium, and these are battery meters. This shows you exactly where your state of charge is. Now, I'm planning on putting BMS on all these, but for testing purposes and trying out my meters, I've got them hooked up without BMSs, but I'm only going to discharge them a little ways and charge them not fully charged. And of course, this is programmable. You can program the inverter to charge at whatever level you want, depending on lead acid, AGM, or lithium, like I'm using here. So it gives you a lot of flexibility there. So anyways, I got probably 3 or 4 kilowatt of power here in lithium, and then of course I got some lead acid underneath, but those are just kind of been hooked up for the wind turbine temporarily. So I am using this box here I got from Missouri Wind and Solar, which is a Coleman Air, and it works okay. And of course it's got a diversion load set up with it. But this right here was the biggest thing I think that helped me. And this right here is a generator, and this is made by let's see, what is the model? It helps know this stuff before you start your video, huh? Anyways, it's a Reliance, and here's the name. And this is a 1, 2, 3, 4, 5, 6. So this has got 6 relays. Now the first 2 come actually bundled together, and it had a 220 in here. So if you wanted to run some 220, which I do not, so I took it out and I put 2 individual breakers in. And then of course I took the piece out that had these tied together, so that let me make these individual. Okay, so then I got these all on different circuits throughout the house. And here's my list. And it comes in the lid. You can label it however you want. And then of course you got the same thing in my breaker box, but A's my master bedroom and the couch, dining area, master closet, bath and wash, which is on one circuit, bedroom. And if you notice, most of these on side A, and then there's a B, because it's a 2-leg system. You have 2 legs coming in. That's how you get your 220. But some stuff is actually on A and some's on B. So, or leg 1, leg 2, however you want to label it. But anyways, with this inverter, it has an in and an out. So this right here is your AC input. Okay, and this inputs, and this plugs right into the AC outlet. And of course I got a watt meter on here, so I can keep track of the AC wattage that it's utilizing or putting back. Now that's the weird thing about this thing, because sometimes it's kind of hard to tell whether you're actually putting power back to the grid, which you do have a meter here. And as you can see, it shows your AC, which is your grid, and this is your panels, and then this, of course, this represents your inverter, DC to DC, and then of course this is the one that's DC to AC, and of course it points down at your battery, so it shows when the battery's fully charged or charging. Right now it's charging, as you can see here on the light, and it's inverting. So right now this is acting as a both off-grid and on-grid inverter. And it's supplying power to my load from the panels. Okay, and all this is coming in from the panels, charging the batteries, applying to the load. And if it gets the batteries fully charged, which I just added a couple batteries over here in my bank. So it's finished topping those off. And when it gets done, it'll start actually pushing energy back to the grid. Okay? So it's also acting as an off-grid inverter. And down here, that comes up here on the front side, this wire I have wired into my box here. And this is what this is a generator transfer switch box. Okay? So what you do is you wire all these up, and you have two sets of wires. You have a red and a black. So the red wire goes into your breaker, your existing breaker in the breaker box. Okay, so I have F going to living room front wall. So living room front wall on the breaker box, let's see, living room front wall is the A here. So I wired that one, and what it is, you go up with a red wire, goes in the breaker, and then that wire you pull out of the breaker, you marry up and wire tie to a black wire that goes back down to the box. Okay, so basically you're letting the box control whether you're on line or you're on generator, and this is like a 3-pole switch. In the middle, nothing. On the downside, when you flip it down, you're on line, which you're on the grid. When you flip it all the way up, you're running on generator, or this inverter, which it pumps out energy out on the output all the time, but you can't run them both together or you're going to have some fireworks. Doesn't work. Okay? But since I isolated all these circuits, and this is my backup as well, so if there's no power, all I got to do is flip these switches, or if they're already up, then nothing's going to happen to these circuits here. They're just going to stay up and everything else will go down. But since I got them on generator right now, because I'm doing that just to let my solar coming in to offset this much usage on all these circuits. And so the only thing that's running is the other circuits that's left in the AC. So that's going to actually help with my usage there. Plus this is inverting, and once the batteries are totally full, and it's not there yet, but you'll see here, there'll start being arrows going back toward this symbol, which means it's feeding back to the grid. So I mean it's producing enough that it's filled the batteries, it's supplied the load, which right now I'm running AC, so it's probably not going to do it because I don't have enough panels. But if we shut the AC off, it will. It'll actually start converting and sending back to there. So I'm cutting down the usage by using this, and you don't have to do anything to your breaker box. That's the nice thing about it. Once it's wired in, you don't have to do anything except move these switches depending on what you're wanting to run off of. So I don't have to worry about anything backfeeding, any dangers, shocking anybody as far as the lineman. And this right here has the island protection, so if it's feeding back to the grid and the grid shuts down, this thing right here will basically stop sending any output back to the grid, and it doesn't put out anything really, because so all those circuits will go dead, and then this one right here will be the only one that's live, but this will continue the running because it's still running from the batteries, it's still running from the solar. If the solar's not out, this will just run from the batteries. Now here's another neat feature about this. You can set this charger to prioritize the incoming power from the panels, and you basically run this without batteries at all. This will function without batteries at all and act as a grid tie inverter and just run off your solar panels, and it goes into like a sleep mode, and of course then it'll wake up when it gets enough energy when it gets daylight, and then it starts inverting and acts like just a regular grid tie inverter. And you can actually pair these up with multiple. This is 2400 watts, and you can add another one and another one and another one. And I can't remember if it's 6 or 9, but you can add several of them together, so that's quite a bit. Okay, so then you're getting double. I mean 24, 48, and so on. Another thing about this charger, and of course this is all in the literature, but I was trying to find something like this for a long time, And I really didn't find very many videos that explained it in detail. And so I just kind of had to take a chance, you know, and see if it's going to do what I want it to do. But this could be programmed to run from the solar and run from the grid. And of course, you know, when the usage at night of electricity is low, your rates are actually lower. So you could program it to run from the batteries and invert that power and supply power to home. And it will actually do this throughout the night as well. And if those batteries get too low, and you could set it in the settings in the software, if they get to a certain point, then this will actually switch. Instead of pulling energy from the batteries, it'll say, okay, we're done. And then it'll start charging them back using the grid power. Now, how many inverters out there do you see that do that? Yeah, I haven't found one. And this, as far as cost, this right here has been the most cost effective. This right here cost me around $700. Okay. And the setup I had before was a charge controller, a grid tie inverter, an off-grid inverter. So I got 3 units. And of course I got to do a bunch of extra crap to be able to run the off-grid and everything else. So, you know, I went with this option. And of course then when I added the box for the generator, and of course I got a gas generator too, okay? I got a backup for my backup. So if something happens, it's not, we haven't got any sun or wind because I have a turbine, then if I have to, I'll get, it's already gassed up, it's ready to go, I'll start it periodically, and then I can plug into this and plug it in an outlet and supply that side of the house, you know, which is the A side, and I already got them labeled. And I know which ones are A, which ones are B, and of course the 220 is not going to be run. You know, it's for emergency use. So I'll shut everything down, shut the breaker off so it won't backfeed, and I'll run the generator. But the sweet part about this is it's a very small system. The guy don't have to spend a lot of money. And so far, I'm very, very impressed with the MPP solar. And I'm basically and I got one panel that got damaged during lightning, and once I fix it, I'm going to be back up to a kilowatt of input, but I can set up another 4 panels, and I got them solar tracking. And that's, you know, I've got a few videos out about that, but my panels track the sun. You get a lot more voltage, you know, not voltage, but, you know, you get more energy throughout the day than you would have panels that are just facing in one certain direction. So I'm able to change that, and it tracks the sun as the sun goes across the sky. And that helps as well. So every little bit makes a difference. But the real meaning was for this right here was to show everybody the MPP solar. You know, I think it's a really cool item. You know, it comes with some free software. You can hook up on your computer. You can monitor your usage and how much it produces. You do your programming and program it to, you know, to the type of batteries you got. It's got AGM flooded and user defined, which basically it lets you define the voltages at pretty much what lithium would be. And of course lipos I think would be probably settable, because I think lipos are a little bit less than a lithium, you know, and these are set up as 24 volts, so I can max them out at, you know, 28, 29 volts and still be fine. And of course I'm gonna get some build me some special balancers and BMSs and get those going. I got the boards ordered. I just got to build them, and then I'll add them to all these. But you know, pretty neat setup. The way I like the way these work. I got these from a guy online. I watched his videos for about the last year or so, Jehu Garcia. You can go to his channel on YouTube, and he's got tons of videos about these boards. He sells the boards. I ordered my own boards and parts, and then I assemble my own. It's just how I like doing it, and it's actually cheaper. But yeah, these are individual cells. So, and these right here are double. So you got one on top, one on bottom. See how the board? You got a cell on top, cell on bottom. So when you get these boards, they're capable of running a cell on both top and bottom. And then what you do is you put the trays on there and solder them on, and use the connectors, which it's got an ICDE connector, and it's actually a 16 ribbon, which what it does, it's getting split into 8 and 8. So and then of course one of them's your ground, and then your other 8 is going to be your 7 cells. Okay, and it's the same way that these right here work, because it works with the same setup. And these right here are battery monitors, so you can see what your cells are doing, you know, what each group. So, you know, this particular light is for this cell group here on the end, all the way down. And then it sees that as one cell. And of course, the way these boards are set up, and they connect through these posts in the front, and then your hot and your negative, and then each one's got this port, and that ribbon actually connects them all together, and that lets you balance them. So if you got it connected to a balancer of some kind, and I actually have a hobby balancer that I use when I first set these up, and I balance them out and get them fully charged, and then I add them to my bank here. Eventually, there's something I want to do too for safety is, as you notice, you got a lot of wood around here, and these things do tend to, if they get for some reason overcharged, burst into flames. But eventually what I'm gonna do is I'm gonna encase this entire area in sheetrock, and I'll do another video. But just for protection, and you know, I'm gonna put a piece of sheetrock on the bottom, which will keep things, you know, insulated, and a piece of rubber for everything to set on. And then I'm gonna create walls which will cover this area up and down, cover the back wall except for the connections, and then come over and come out, and then put a door on the front of this, so it would actually go across here and up. And so it'll all be encased with sheetrock. So, you know, and you know, of course it'll have some ventilation for letting heat out and circulation. But if there was to be a fire, then it would help contain it, because the fire properties of your sheetrock is a lot better than just regular old plywood. As you can see, this is a shelving that I created for my garage, and you know, it's, at first I was going to build this up and beef it up real heavy for lead acid, and then I got to studying on the lithium and watching some people that were using lithium for DIY and power walls and stuff, and I was like, you know, they got to be a better way than just buying a crap load of lead acid batteries. And believe me, I've been messing with lead acid batteries. I recondition them, and those right there I reconditioned and got them working, and so know a little bit about it, and I take care of a lot of people's golf carts and stuff, reconditioning them, and it's a pain. You know, you got to make sure you equalize them periodically. You got to make sure they're full of water. If they run out of water, you damage them. So lots easier. No fumes. Okay, no fumes. If these run down and stay down for 2 or 3 days, a week, as long as you don't run too low and damage the cells, then you just charge them back up. They can set for the longest time. You lead acid batteries, not so much. Okay, guys, I want to end this 18 minutes at MPP Solar. I think it's going to be a pretty good thing. They actually got a 48 volt version I almost went with, but you can do pretty much the same thing. The voltage is 48 volts, okay, but you know, it accepts a lot higher voltage, but your bank has to be 48 volt. But it's $1,200 unit. This is 7. So you know, it's for the longest time I had all these tied together and was using 48 volt system, but my panels are capable of working just as fine with 24 or 48. So they put out 31 volts. So either way, and of course this right here, I can series them together for over 100 volts. And this thing right here, the nice thing about it, you know, it will invert that energy and charge my batteries at 24 volt, create energy for the house, and if it creates enough, it's going to send it back to the grid. So get you one, try it out, guys. Very, very programmable. I mean, you can set options in the software to how you want it to charge. You can say no charging from the grid, only charge from the solar. Lots of different options, what you want priority wise, and you know, you won't get that with a lot of chargers out there and inverters that pretty much are about the same cost, and you just got a bunch of lights to look at. You actually got software. It will keep track of your daily usage, or production rather, so you know how much you're producing from your panels, and upgrade accordingly. So take care, guys. Come back and check out. I'll try to put out videos from time to time. If you like and share and subscribe if you want. It's Quentin Craft. We're out.